This video is about factoring, which for some of you may be a review, and for some of you it may be new. This is going to go through everything, not everything you need to know, but a little bit about factoring. So what is a factor? A factor is a term that evenly divides a number or expression, evenly meaning without leaving a remainder. So for example, 1, 2, 4, and 8 are factors of the number 8 because they all evenly divide 8 without leaving a remainder. We can write a number as a product of 2 or more factors. So 8 can be written as 1 times 8, or 8 can be written as 2 times 4. So when we're talking about factoring, it means that's when we write a number or expression as its product of 2 or more factors. For example, the polynomial x cubed plus 2x squared minus 5x minus 6 could be written as the product of 3 factors, x plus 1 times x minus 2 times x plus 3. Or another example, the binomial 3x squared minus 5x minus 12 could be written as 3x plus 4 times x minus 3. I think I just called that a binomial. It's a trinomial. I apologize. So the trinomial 3x squared minus 5x minus 12 can be written as the product of 2 factors, 3x plus 4 times x minus 3. So when we're trying to factor trinomials, which is what we're going to be, what this video is going to be about for the rest of the time, well, we need to know what trinomial is and binomial is. You heard me just mess those two things up, so let's try to be clear. A trinomial is an expression with 3 terms. A binomial is an expression with 2 terms. And a trinomial can sometimes be factored to the product of 2 binomials. So when we do this, we can use the area model. So for example, 8 equals 2 times 4 could be seen as finding the area of a rectangle that has the length of 2 and a width of 4. So the area of the rectangle is length times width, which is 2 times 4, which we know is 8. Which this may seem kind of silly to do right here, but we can use this idea to help us when we're trying to write something as a product of 2 factors, which is what we're going to try to do when we're trying to factor a trinomial. So let's look at the area model of 156. Still not a trinomial, but we can look at how we might be able to break this number, 156, up into different parts that we can then use to help us factor trinomials. So we have another rectangle. Looks kind of like a square. Doesn't have to be a square. Any kind of rectangle. And we know that we can write it as length times width, but 156 might not be the easiest number to find the 2 factors of. So we could break it down. Now, this isn't necessarily going to make it easier for us, but this line of thinking is going to make it easier when we actually have to factor trinomials. So we can break this up into different parts, this rectangle, and find the area of each part. So let's say we want to break it up so that that first one, that first giant rectangle that's actually a square is 10 by 10. Which means that the area is going to be 100. Great. Well, that leaves us with this blue rectangle, this green rectangle, and this pink rectangle. And the total area of the whole entire large rectangle is 156. That has to be the 100, that gray part, plus the blue, plus the green, plus the pink. All of that has to equal 56. The blue plus the green plus the pink has to equal 56. Okay, so we already know that the blue part, we know that the length is 10. We don't know what the width is. The green one has a width of 10. We don't know what the length is. The reason we know these things is because this right here, this length, has to be the same as the length of the gray one, which we know to be 10. And this width right here has to be the same as the width of the gray part, which is also 10. So we know that some things about the blue and the green, but we don't know everything. What else do we know? Well, we also know the area of this pink part right here has to end in a 6, because if this part's 100 And this part is 10 times something. It's going to end in a 0. This one is something times 10. Also ends in a 0. So that means that in order to get 156, this has to end in a 6. Could be 6, 16, 26. Not sure. Let's keep going. Well, we can just play around with different numbers and see what works. 10 times 3 is 30. And if that were true, then this up here, the width, that means the width is 3. And we could say 2 times 10 down here, which means that this length has to be 2. Well, we have 30, and we have 20. That adds up to 50, which would mean that we would need the pink to be 6. And in fact, the length here is 2, because it's the same as this. And the width here is 3, because it's the same as this. So the area is 2 times 3, which equals 6. Perfect. So we can check that. So our 156 equals 100 plus the area of the blue rectangle, which is 30, green rectangle, 20, pink rectangle, 6. Yes, that adds up to 156. But remember, our original question is, what are the two factors? So 156 is equal to something times something. Well, we have to think back. What are we actually looking at? We're looking at the giant rectangle, this whole thing here. And we're saying that the area is the length times the width. Well, here's the width, here's the length. So we could say that this question mark is this whole side right here. So that's 10 and 3 together, or 10 plus 3, which is 13. This whole entire width here is 13. Same could be done over here. This whole length here is 10 and 2 together. So that's going to be 12. So we have one question mark as 13, the other question mark is 12. In other words, we can write 156 as the product of the two factors 13 and 12. Okay, that was a lot of work to get to something that we probably could have just found directly, but this idea is going to help us with the trinomials. So how do we know what goes in the blue and green rectangles? Well, we have to notice that 10 times 6 is equal to 600, and 20 times 30 is equal to 600. 100 times 6 and 20 times 30. Let's take a look at that some more. So right here, this 100 times 6 is 600, this 30 times 20 is 600, and I'm not going to go into why right now, but that's always going to be the case. So we can use this information to help us figure out what number is going to go here and what number is going to go here. All right, well, let's use this in an example with an actual trinomial now. So if we have the area model again, and we're going to try to use the area model to factor the trinomial 3x squared minus 5x minus 12. So here's our rectangle, the area of which is 3x squared minus 5x minus 12, and we want to be able to write that as a length times a width. So we start the same way, we're going to break it up into different parts. And this part doesn't have to be a square. I kind of made it look like a square, but it doesn't have to be. And in fact, in this case, it won't be. Because the length and width have to multiply to become 3x squared. If we're sticking to whole numbers, we have to have 3x and x. That's not going to be square. 3x is going to be longer than x. So this picture is not drawn to scale, but we're using it just as a way to help us think through the problem. So the area there, like I said, is 3x squared. But this time we know something a little bit more about the small rectangle over here. That's going to have to equal negative 12. How do I know that? Well, that's the third term of my trinomial. It's the term that doesn't have an x in it. This one here is definitely going to have an x. How do I know? Because the length is 3x. This here is going to have an x. How do I know? Because the width is x. So the only part that can't have an x in it is this pink part. So that means it has to be negative 12. The area has to be negative 12, that pink rectangle. So that means that the total area of the entire thing has to be 3x squared, which is this part, plus the blue rectangle, plus the green rectangle, plus the pink rectangle, which we know to be negative 12. So that means that the blue rectangle plus the green rectangle together have to be negative 5x. Why? Well, we already have the 3x squared. We already have the negative 12. So the only thing left is negative 5x. So those two combined have to equal our negative 5x. Great. But how do we know what they are individually? We know that they add up to negative 5x. How do we figure out what the blue rectangle is and what the area of the green rectangle is? In order to do that, we have to know a couple things. Well, first of all, we know that something about that blue rectangle. We know the length is 3x. We just don't know what that width is. Similarly, with the green rectangle, we know the width is x, but we don't know what that little length is. So what do? Well, we have to think back to that last slide, and we know that the area of the corners, when you multiply them together, is the same as the product of the other two. In other words, the area of the blue rectangle times the area of the green rectangle is equal to 3x squared times negative 12, which is negative 36x squared. So when you multiply these two together, you get the same thing as these two. So we can use that information because now we know that we have whatever the area of the blue rectangle is. When you multiply it to the area of the green rectangle, it's negative 3x squared. And when you add them together, it's negative 5x. So we know that negative 9x and 4x multiply to negative 3x squared and also add to negative 5x. So we can put that in. So the area of the blue is negative 9x. The area of the green is going to be 4x. So if this is negative 9x and the length is 3x, that means the width has to be negative 3. Over here, if we know that the width is x and the area is 4x, that means that the length has to be 4. So now, look, we have a length. This is x and this is negative 3. So together, that's going to be x minus 3 or x plus negative 3. Similarly, over here with the length, we have 3x here and 4 here. Together, that's going to be 3x plus 4. So our two factors are the length and the width, x minus 3 and 3x plus 4. So we can write our trinomial, 3x squared minus 5x minus 12, which represented this entire area, as the length times the width, 3x plus 4 times x minus 3. And that's how you can use the area model to factor trinomials. So in summary, a factor, those are the terms that divide an expression evenly. You can rewrite many things as a product of two factors. To do that, use the area model. Trinomial, when you're trying to factor a trinomial, we know that the top right and bottom left, top right times the bottom left is equal to the top left times the bottom right, and the top right plus the bottom left is equal to the middle term. After you find the inside, the areas of all the parts, you still need to find the outside, the lengths and the widths of all the parts. So after you've done that, you can rewrite your area as a length times a width.